Alright, we are in Unit 2, Section 1, Objective 2.1a2. The objective is the student will be able to rationalize the denominator containing radicals. Rationalizing the denominator means to clear the denominator of all radicals. So we cannot have any sort of square roots, cube roots, fourth roots, etc. in the bottom of a fraction. We have 6 examples that we're going to go over today. And we're going to work on rationalizing the denominator. To start us off, we have the fraction 2 over the square root of 5. To rationalize the denominator, what I need to do is multiply both the top and the bottom of the fraction by something that will help me get rid of the square root of 5. What I can do is multiply the top and the bottom of this fraction by the square root of 5. When I multiply fractions, I multiply straight across. So this is going to be 2 square roots of 5 over the square root of 5 times the square root of 5. The square root of 5 times the square root of 5 is going to become the square root of 25. And the square root of 25 is 5. So this is going to be 2 square roots of 5 over 5. Now I don't have a square root or a radical in the denominator. And all I have to do now is check to make sure that I can't divide 2 by 5, which I can't. I also can't divide the square root of 5 by 5. So this is as simple as this fraction is going to get. And that's what I'm going to keep. Okay. Example 2. I have 2 times the square root of 16 over the square root of 9x. Well, right off the bat, I know that the square root of 16 is going to be equal to 4. And I know that the square root of 9 is going to be 3, but I'm going to go ahead and break that up first. So the square root of 9, like I said, is going to be 3. Up top, I have 8 over 3 times the square root of x. So the only thing I have to get rid of right now is the square root of x, because that's the only thing in a square root. What I need to do is multiply the top and the bottom of the fraction by the square root of x. Up top, I'm going to have 8 square roots of x over 3. The square root of x times the square root of x is going to be the square root of x squared, because x times x is x squared. When I take the square root of something squared, I know that this square root symbol and this exponent cancel out, and I keep what's in the middle. So my fraction is going to become 8 square roots of x over 3x. I can't divide 8 by 3. I can't divide 8 by x. I can't divide the square root of x by 3 or x. So that's where I'm at. Up next, I have the cube root of 1/2. So when you're taking the cube root of something, it's a little different. Same idea. I can't have any sort of square root or cube root in the denominator. I'm just going to break this apart into 2 cube roots. Up top, I have the cube root of 1, which I know is going to be 1, because 1 cubed is 1. In the bottom, I have the cube root of 2. Now, what I'm going to do is multiply the cube root of 2 by something that will help me get rid of that cube root. That's going to be the cube root of 2 squared. And whatever I do to the bottom, I also have to do to the top. Now, the reason I chose to multiply by 2 squared is because what's inside the radical gets multiplied. So I have 2 times 2 squared. This is actually going to become 2 cubed. And just like in example 2, when I have the cube root of something cubed, those exponent and the square root are going to cancel out. I keep what's in the middle. So I have the cube root. Up top, 2 squared is 4. And underneath I have 2. I cannot divide the cube root of 4 by 2 because 4 is inside that radical. So I'm not just allowed to divide. Just because I know I can divide 4 by 2, it doesn't mean I can divide the cube root of 4 by 2. This is as simple as that fraction is going to get. So that's where I stop. Example 4, I have the square root of 7x over 3y. I'm going to take the square root of both top and the bottom. Now I need to multiply both the top and the bottom by something I can use to get rid of the radical in the denominator, which is going to be 3y. Up top, 7 times 3 is 21. I have an x and I have a y. Okay. In the bottom, I have the square root. 3 times 3 is 9. Y times y is y squared. I can't change anything with the top, so I'm going to leave it as is. In the bottom, the square root of 9 is 3. The square root of y squared is y. So I'm going to have 3y. I can't divide the square root of 21xy by 3y. I know that I can divide 21 by 3 and I can divide y by y, but because of this square root symbol, I can't do that. So I'm going to leave it as is. Example 5, I have the fourth root of x divided by the fourth root of 81 y to the fourth. Now, this looks complicated, but the fourth root of 81 is 3. And the fourth root of y to the fourth is y. So really my denominator is 3y. I don't have a radical, so I don't need to rationalize. This is as far as this problem goes. Can't simplify, don't have anything to get rid of. I'm done. Example 6. I have the cube root of 2 over 9. This means I'm taking the cube root of 2 and the cube root of 9. I'm going to multiply both the top and the bottom of this fraction by the cube root of 9 squared. Remember, because this is a cube root, I need something I can take the cube root of, which means I need something cubed. I have 9 times 9 squared. Well, that's going to be 9 cubed. And I can take the cube root of that, which is perfect. Up top, I have the cube root of 2 times the cube root of 9 squared. So I need to multiply 2 by 9 squared. 9 squared is 81, and 2 times 81 is going to be 162. In the bottom, this cube root and this exponent cancel out. I keep what's in the middle. So this is going to be the cube root of 162 over 9. I can't take the cube root of 162. This is as far as I can go with this problem. All right. That is how to rationalize a denominator.